The path of least time. Equipment needed includes a stopwatch, a metronome, the path of least time worksheets, and a ruler. Now, for the metronome, you can use an app. I found one called Metronome Beats. There's probably others. Or a 60 beat per minute YouTube video. There's plenty of those for drummers. The worksheets are in files. And the ruler, the worksheets are actually 1/4 inches, not centimeters. So it's a 1/4 inch by 1/4 inch grid. So use a regular ruler, or I actually made a ruler out of a couple of worksheets so that I was sure I was using the same dimension as the worksheet grid. Our objective is to discover the fastest path from point A to point B, such that our speed in region A is different from our speed in region B. We will then compare our measured values to some calculated values. As an example of this problem, here's a lifeguard that can run a certain speed in sand and swim a different speed in water. So to help the person in the water, should the lifeguard run straight along path A and then swim so it's all a straight line, or is there a better option where, for example, path B, you're running longer and swimming less, and path C is something in between? So what would be the path of least time if in two different regions, sand and water, you travel at different speeds? So the worksheet is a 30 by 36 unit grid divided into two sides by a red line, right? The left is side A, which includes point A in the lower left corner, and the right of the red line is side B, which has point B in the upper right corner, right? So this example shows where point C is a certain height y above the bottom, and the dotted line is the normal or perpendicular to the red line, and I've indicated angles A and angles B. So the procedure will be to set the metronome for 60 beats per minute. So that's 1 beat per second. For different points C on the red line, we'll start at A, and we'll start on a beat, and every beat will move 1/4 inch on our ruler until we get to point C. Then, starting from C, we'll follow the path to point B, but we'll skip every other beat. So if we start on a beat, we skip the second beat, and then on the next beat, we land on a point on the ruler 1/4 inch along that path to point B. I'll demonstrate this in a moment. So another option to get the time, instead of a stopwatch, is to actually just count the beats, because every beat will be a second. And the worksheets look like this, where here's one where point C is a height y0 above the bottom. And then here's a couple where on the left, point C is y equals 9 units, and then to the right of that, the point C has y equals 18. And then the last two is y equals 27, and then y equals 36, which is the top of the worksheet. So in order to demonstrate the procedure, I have the 60 beat per minute metronome going. I have a ruler taped down, and there I am with the worksheet. Start on a beat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 and a half, say, right? So 14 and a half beats, that's 14 and a half seconds to go 14 and a half units, right? Because I traveled at 1 unit, which is 1/4 inch, every beat. And now we go from point C to point B, but skipping a beat every other beat, right? So we'll travel 1/4 inch or 1 unit every 2 seconds. Start of the beat. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we just keep going to point B, right, keeping track of the total number of beats, which is the total number of seconds. And so we had beats from A to C and beats from C to B. So we would, and we might have had to estimate a fraction of a beat when we landed on the endpoint of that segment. We would add that up. That we would want our total time from A to B to record in our data table. So now we can set up our data table. We'll have a column for Y, which is the distance from the bottom of the worksheet up to point C in units. We'll have the time that we measured in beats, which are seconds, and getting from point A to point B through that point C. We'll calculate the angles theta A and theta B that will be mentioned in a moment. And we're also, it may not be clear why we're doing that now, but we will calculate the sine of theta A divided by the speed in region A. And we'll also calculate a column for the sine of theta B over the speed in region B. Now, the speed in region A is 1 unit per second because we were moving 1 unit every beat or second. But the speed in region B is a half a unit per second because we moved a unit every 2 beats or 2 seconds. The very last column is the percent difference of the two preceding columns. In other words, the columns involving sines and speeds. The last column is the percent difference between those two columns. And the Y values that we will use are 0, 9, 18, 27, and 36 units. Each of those is represented by a separate worksheet that has the path drawn for you. So you'll measure the time as we demonstrated for those paths. And then, again, the remaining columns are calculated. Now, if you look at the column of times, you may see that one of them is smaller than the others. So to get a little closer to the minimum, you can also try some additional points. For example, suppose at y equals 9, you find that that's the smallest time. Then try 2 more points at 3 units smaller and 3 units more. In other words, if say y equals 9 gave you the minimum time with the values you have so far, then try y equals 6 and y equal 12 as well, and add those to the table. So a little more about the worksheets. For a given point C, that is a certain y above the bottom of the worksheet to the point C, you can calculate the length in region A and the length in region B. Now, knowing the speeds in region A that we're using, which is 1 unit per second in region A, and 1 unit every 2 seconds, or 0.5 units per second in region B, we could also calculate the times that, as a way to compare our measurements. So the time in A is length A divided by speed A. Time in B is length B over speed B. So the total time is the sum of the times in each of the regions. Now in Excel, we're going to actually do a continuous line graph for all y from 0 to 36 in increments of a unit. And we'll overlay on that a scatter plot of our specific data points, and we'll see how well they come together. So I'm showing you the formula for time, and then for Excel, how that would be entered. So in Excel, I have a column for Y and T, and for Y, we'll just go from 0 to 36 units. So I put in a 0, 1, and just copy that pattern down. There's my 0 to 36 units. In the time column, I'll put the formula in that I showed previously, but the word cell actually has to be the Y cell, which is A2, and when pasted down, will become A3, A4, etc. So there we have our A2 where the cell placeholder was, and now I click on the little black square in the lower right corner, and that fills down. So now I have a column of calculated times, theoretical times, and let's insert a continuous line graph. And since I wanted to sort of, half of that graph, the lower half is empty, let's just change the y-axis a little bit, and maybe we'll make the lowest point 60 instead of 0, and then it'll show more of the behavior. And there we go. Now we just need to overlay as a scatter plot our data points.